decays at a rate of change of 3.5% per hour. What percent of the substance is left after 6 hours? So let me just do a quick example here. We have an X and Y here. If I were to say, let's label our X and Y. Remember, X is always the input, and we're talking about hours here, so I would say X is hours. And the Y, well, what are we talking about every hour? We're losing something, right? We're talking about how much percent there is left. So let's start with a little example. So when at hour 0, when no time has passed, do you agree that we still have the original amount? We still have 100%? And then what happens in an hour? We're saying that this decays. The word decays is you're losing. It's going down. And it's going down how much, guys? It's going down 3.5%. So what's 3.5% of 100? So if you in fact wanted to multiply them, you would turn 3.5% to a decimal, which if you remember, if it's a percent, divide by 100 and you will get its decimal, which is 0.035, right? So that will give me 100 times 0.035. So you're saying after an hour, we have 3.5% left? No. Here's a very important thing we need to learn, guys. We're not talking about how much we're taking away. We're talking about how much there is left. So we're not multiplying by 0.035. We're multiplying by how much there is left. So if we have 100% minus 3.5, how much is left? 96.5%. All right, 96.5 divided by 100, that turns into the decimal 0.965. When you multiply these two, we get 96.5. Da-da-da. And now you might be wondering, Mr. Milano, couldn't we just have subtracted and gotten the same answer with all this mumbo jumbo? Yes, you could have. However, how do you think you're going to solve the second hour? A lot of people might say, oh, Mr. Milano, just subtract by 3.5. No, because this is your new 100%. That's your new total. So you got to keep doing the same thing, times 0.965 to see how much you have left. So times 0.965. So you actually have 93, and put it in red, 93.1225. And you basically just found out, what are you doing over and over to this thing? What do you have to do over and over to find the decay, the rate of change? And you guessed it, we're multiplying the same number over and over. Now, if you guys don't remember sequences, this actually talks a lot about our common ratio. If you guys don't remember, is our y equals, because we're multiplying, it's a geometric sequence. It's always the initial term times the common ratio to the power of x. And well, we know a couple of things already. Don't we know our initial term? Our initial term was actually 100%, wasn't it? So we know it's 100. Do we already know what we're multiplying over and over? Yes, we do. 0.965 to the power of x. We got a nice little formula to solve this. Now, what's the question we're being asked? How much would there be after 6 hours? Hours is the x. So all you have to do, guys, really replace this with 6. And let's go to decimals. Your good old friend, Mr. Decimals, will show you how to do this. Let's go on decimals, and let's see what it says. You don't have to type the y equals. If all you did is 100, look how easy this is. Parentheses 0.965, parentheses, a to the b, that little button right there, boop, 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 to the power of 6. You found your answer. Your answer is actually 80.75, if you want to round, percent left. So that's how much you have left in the 6 hour. 6 hour. And that's basically what you do. Create your formula and you'll be fine.